So we're just gonna do the exact same thing, but from the pole's perspective?
We're gonna use the Lorentz transformations to get from the pole's point of view.
Okay.
Because once we establish what we know from one point of view, we can use the transformations in order to figure out what's going on at the other point of view. So from the pole's point of view, for event 1, x prime is equal to 2, which is gamma, times x minus v times 0. I'll do this one for you. All right. T prime happens from, let's see, so we do 2 times 0 minus v over c squared times 0. I'll get this one for you too. 0. That's meters and nanoseconds. So it's 0, however many seconds, whatever unit you want to use there. So from the pole's point of view, event 1 happens 0 meters and 0 nanoseconds, and that's fine, because what that says is as soon as that left pole enters here, the door closes. It's an instantaneous close. Think Star Wars Episode 4, when the door was going. But if you don't know what I'm talking about, you really need to see Star Wars again.
I was just gonna say it was an instant door.
Okay, yeah. So as soon as the left pole enters, the door closes. It's right there at the left end of the pole, so that's why the position should be 0 meters, and we synchronize our clocks at that point, so time is 0. It's all beautiful. Event 2. The right door closes. All right, the right door closes. Let's see, so we have x prime. So this is 2, this is 1. x2 happens, so I got my x and time right there. So x prime for 2 is going to be 2 times 10 minus v times 0.
Wait, where does the 2 come from?
Gamma. Because from the pole's point of view, the bar's traveling at 0.866 times the speed of light. And T2 prime is 2 times 0 minus V over C is 0.866, so 0.866 times 10 divided by 3 times 10 to the 8. I got the first 3, so
Is that just a simpler version of the speed of light?
3 times 10 to the 8th?
Yeah.
Yeah, that is a much simpler version. In the lab, I wanted you to be more precise, but for here, we'll call it universe 2.
Our neighbor.
Is that?
Our neighbor.
That's right.
Negative 5.773 times 10 to the negative 8.
Negative 57.3 nanoseconds.
Yes.
Is the negative sign? Well, first of all, is it right? It should
Yes.
be negative. Is that because event 2 is right door closes? My thing is the right door is still in front of the pole at this time
Yep.
because it doesn't go out the other door, and so I would think it'd be positive.
So 0 seconds is at when the last part of the pole enters.
Yes.
So that's just saying that the right door is going, or it's the right door, right? That's event.
Correct. This is the right door.
It's saying the right door is gonna close before the whole entire pole is in the barn, from the pole's point of view.
Yes, that's exactly what it's saying.
Okay.
That seems to trouble you.
No, it's just the negative sign threw me off, but that makes sense what he said.
Okay.
It's just before pole enters the park.
So I understand the math, but why does that happen?
because the speed of light is constant regardless of the reference frame. And it does all stem from that one thing.
It doesn't care about your feelings. Just
So-
is.
It is a crazy concept.
You kind of just have to accept it the way it is.
There's enough experimental evidence to make us all believe, I say all, to make physicists believe it is true. Number 3. Event 3 is when the pole hits the right door. So x3 prime is going to be 2, because that's gamma. Let's see, using the top formula there, x is 10 minus 0.866 times the speed of light, 3 times 10 to the 8, times the time of 7.7 times 10 to the negative 9.
Is negative 9, never mind. This
Negative.
is negative.
And while that's being figured out, we can at least write down the formula for T3 prime. Again, just plug and chug into this formula right here. So I know gamma is 2, time is 7.7 times 10 to the negative 9, minus 0.866 times x, which is 10 over 3 times 10 to the 8. Alright,
For X prime, I got 15.999 or 16.
okay. Which makes sense from the pole's point of view. When the pole hits it, it should be, from the pole's point of view, whatever's happening over here should be 16 meters away from 0. So we should feel good that something went right because it comes out to the length of the pole.
So from the perspective of the pole, even though in this scenario the pole does shrink and fit into this barn, but from the pole's POV it doesn't shrink,
Correct. The barn shrinks.
or would the barn expand?
From the pole's point of view?
Yes.
From the pole's point of view, the barn's shrinking because the pole's not moving. The barn's coming at it at that speed.
What if it shrinks and it's already too small to fit it in? How does that help?
That's what the timing's helping us with. We'll sum it up as soon as we get this last number.
He goes back in time. And you said negative time doesn't exist.
Negative time is just before time is equal to 0. There are certain situations in which negative time does not make any physical sense. Like projectile motion problems.
Negative 42.3 repeating nanoseconds.
All right. So we have these 3 events. From the barn's point of view, left and right door happen at the exact same time, both doors close, and then the pole smashes into the right door. From the pole's point of view, the right door closes, the pole smashes into it, and then the left end makes it inside.
So it goes like right door, pole hits the wall, and then last door closes afterwards.
Yep.
Is that because from the pole's point of view, it's too big to fit in?
Oh yeah. From the pole's point of view, that barn is 5 meters long.
Well, I'm saying that's why all that happens.
Yes.
Okay.
And when that left, the left door closes, does this problem, I don't know if this involves a problem or what comes afterwards, but does that last door hit the pole? Or is it like the pole all the way inside?
When, like, for the whose point of view?
After the problem, the pole, from the pole's point of view, it hits the far right wall,
Correct.
and then the left door closes.
Correct.
So does that left door actually hit like the top of the pole, or is the pole all the way inside?
The left in has just come inside when the left door closes.
Wait, so it's like stretch.
Yeah, so,
I think I'm thinking too much about what happens afterwards.
all right, let's see if we can draw some absolutely epic drawings here. All right, so barn's point of view. We end up with, so this is 10 meters long, 8 meters, close, close, and then it hits. So this would be 7.7 nanoseconds.
Yeah.
Pole's point of view is, first thing that happens is left door closes at negative 57.3 nanoseconds. Then, pole is still outside of it. Let's see if I can draw that better. So pole's point of view. This is 16 meters long. And the barn
10.
is 5 meters long. They cut in half. Then left door closes. We didn't actually calculate when the right end of the pole enters the barn. So it could be inside at this point. Right door closes. Then the pole's not moving. Then it smashes into it. So this happens at negative 57.3 nanoseconds. And this happens at negative 42.3 nanoseconds. And then, the last bit, again, 5 meters long. And this happens at 0 nanoseconds.
So, from the pole's point of view, it breaks the barn.
They both break the barn. Because the pole hits, in scenario, in event number 3, the pole was hitting, in both cases. Wait, no, sorry, strike that. Yeah, event 3, from the barn's point of view, the left side enters, left door closes, right door closes, and then the pole hits the right side.
Presumably.
So, there's not a scenario where the left door does not get hit by the pole. That is an event that happens, it's just a matter of the timing.
Can you, that last thing on the pole's POV, is that the last picture, is that, the pole hitting the left wall?
This is when the pole hits the left wall.
Is that not the right wall?
Oh, sorry. That's what happens when I erase left and right.
No, you're fine, I'm just trying to understand.
So this last scenario is the left end of the pole has just entered the barn and the left door
Yeah.
closes.
And
The left door was not damaged for the barn's point of view or the pole's point of view.
so in that last one, the pole's like sticking through the right wall?
Yes.
Okay. That makes sense.
And 0 nanoseconds for the barn's POV is not the same as 0 nanoseconds for the pole's POV, right?
They've synchronized the clocks so that when the left end enters, 0 nanoseconds is the same for both.
So physically, how can the pole be hitting the wall and going through while also not touching the wall at the same exact time?
I think that's the point, it's not the, oh, how can it be through at 0 nanoseconds and not through at 0 nanoseconds?
Yeah.
Okay.
It might be above our pay grade of $0 we're paying.
They would not do, that, you were right the first time.
So the 2 nanoseconds are different for both?
Yeah, other than you do establish that 0 nanoseconds is the same for both. No, but you've got the other stuff happening. Negative time would happen before that. So from the pole's point of view, you break everything and then you synchronize.
Well,
From Barnes' point of view, you synchronize and then you break through. So they are happening.
my understanding is, like on the 0 nanoseconds on the last, from the pole's POV, the left end of the pole is entering at the beginning of the barn.
Yeah.
And on the other side, 0 nanoseconds is the barn eating the pole, like the last bit of the pole coming into the barn.
Yeah.
So that's the same.
Yeah, you synchronize the clocks then, just the events happen at different times. So negative. I think then, so negative 57.3 nanoseconds is in the pole's time frame based upon the fact that the left end is inside the barn at 0. So that negative 57.3 nanoseconds, when the right door closes, would equate to 0 nanoseconds in the Barnes point of view. So they're two different clocks. They have to be.
Okay.
Let's look at this a slightly different way. If I have a position time axis, I have an event that's happening here in one reference frame. If you have an object that is traveling relativistic speeds, well, even if not relativistic speeds, but we just don't notice those, the prime frames sort of distort my axis. They're no longer perpendicular in the traditional sense. So let's pretend it will show this color. X prime, T prime. And so they're looking at the same event from two different distorted views. Now, the way you figure out a time and event, if you're looking at a graph, if you have a point on a graph, then I still don't know why red doesn't show up here. It's not red. To figure out the time, you go to that X value, you go up to the data point, and then you go parallel to the time X-axis until you get to the time axis. That is the time at which that event occurs. That's the position at which that occurs. If we look at it from the other point of view of the prime frame, then we have an event happening at this X prime value here, and go parallel to the X prime axis until we get to the time axis, and then we have, that would be T prime, and that would be X prime. So in the case of the barn, we have, so right door, left door closed, so I've got this data point here, and then the last one, 10 meters and certain amount of time. So that's the scenario. So left door closes, right door closes, this is like X and time axis, and pole hits barn. From the pole's point of view, my axes distort. And so it's my X prime, T prime. So we still have this axis here that's still 0, 0, but the right door closes, go parallel to the X-axis till we get to the time axis at that time, and this event happens at that time. So we get a reversal of the time in which things happen, and this matches what we're showing right there.
Would this be a lot easier if we could do derivatives in this class?
No.